Hi everyone, I am Dr. Sakthi Kumaresh, Associate Professor and Head BCA Department. Today we are going to see Introduction to Machine Learning. Have you ever wondered how Netflix recommends your favorite movies to watch or how your phone recognizes your voice? The answer lies in machine learning. In today's world, people are revolving around data and they are curious to know about insights in data. Yes, we are witnessing fourth revolution of data. Let us take an example and see what is structured and unstructured data. If we want to predict the customer preference towards a product, we take customer data which is of structure in nature. Suppose if we want to do sentiment analysis on social media data, the data will be in unstructured form. So machine learning helps us to arrive at predictions and the outcomes based on both structured and unstructured data. Machine learning has added another dimension to the way we perceive information. Google News and Facebook News uses machine learning to analyze what you read, how long you read, and the posts that you like and dislike. This personalization of information is used in machine learning in order to match your feeds based on your behavior, based on your location, and based on your mood. So Google also uses machine learning in order to provide appropriate results with the help of browsing history. Let us come to the definition of machine learning. Machine learning is a branch of artificial intelligence that enables systems to automatically learn from data and improve performance over time without being explicitly programmed. This means the machine learns from the data and is able to do analysis and gives the results or the outcome without the human interaction, without human coding the data, the machine is able to give the outcome. So let us see how machine learning works. So this image tells you how machine learning works and how the feedback from this helps to retrain the model or improve the performance of the machine learning algorithms. So the input data is given and this data is analyzed. Here during analysis, pre-processing of the data is done where data cleansing is done, dimensionality reduction is done, and feature extraction is done. So once data analysis is done, the next step is finding patterns from the data. So the ML model used in order to find the pattern from the data, and based on the patterns it has observed, it will predict the results for the given data, and the results are stored as feedback. This feedback data helps to analyze the performance of the machine learning model, and also it helps to retrain the model in order to improve the performance. Let us take a real world analogy in order to understand what is machine learning. Think of ML like teaching a child. Rather than giving step-by-step instructions to the child, we show examples and the child learns patterns over time. Let us take an example here. So here we want to teach a child about the different fruits, apple and orange. So here we will not tell the child that apple is round in shape, it is red in color, it has smooth surface, and orange is round and it is orange in color and it is pulpy. Instead, we show the children a set of apples and set of oranges. The child looks into the fruit and learns a pattern and stores it in memory. Next time when we show the child the fruit apple or orange, the child will be able to recognize that it is apple. So from this what we can conclude is that machine learning mimics the natural learning process, that is learning by example and not by fixed rules. So before we go on to the basics of learning machine learning, we need to understand certain terminologies like features, label and model. So what is a feature? Feature means the measurable property or the input that we give it to the training model. And the label is the output or the target data that we want to assign it to the data. And a model is a system that learns patterns from features in order to predict label. So in this example, we have a set of training data. So in this, the data that we are giving as input to the model is the sleep quality of a person, stress level and weight. So from this data, we want to predict whether a person will get migraine or not. So these are some of the training data which we have observed earlier, and therefore for this set of input data the label is already assigned. So when we give input to the machine learning model, we have to give the feature and the label. So based on this pattern, the machine learning algorithm will build a model and when a new test data comes in, it will be able to predict whether a person will get migraine or not. Let us see the difference between machine learning and traditional programming. So in traditional programming, what we do is that we follow rules, that is syntax, and with the help of which we write coding, and we also give input data. So we give the coding and the input data, the system will generate the output. But in the case of machine learning, we give the data, that is features that we want to represent in the training data, that is called data, and we also give the labels. Labels are nothing but the expected outcome or the expected output for the given set of data. So we give training data where it has features and labels as an input to the ML model. The ML model will learn the pattern and it is able to build the model. So when any new data comes in, with the help of this new model that is built, the outcome will be predicted. So this is how the machine learning differs from the traditional programming. So we have different types of machine learning algorithms: supervised learning, unsupervised learning, and reinforcement learning. In the case of supervised machine learning, the machine learning algorithm works on labeled data. In the case of unsupervised learning, machine learning works on unlabeled data and it tries to find the hidden pattern. And in the case of reinforcement learning, the machine learns on its own. Let us say in brief about what is supervised learning. So as I told you earlier, supervised learning works on labeled data. A supervised learning algorithm learns from the labeled trained data and it helps to predict outcome for unforeseen data. The typical example which I gave you in the previous slide about the person getting migraine or not, where it had a set of training data with features and label, and the machine learning builds a model based on which it can predict whether a person gets migraine or not. So that is an example of a supervised learning, and the algorithms that can be used for this supervised learning are linear regression, decision tree, KNN algorithm, and we have much more algorithms also. And one use case that can be again told for this supervised learning is that spam detection in emails. So we give a set of emails as a feature data along with the label whether the email has spam or not. So based on this pattern, the machine learning algorithm builds the model, and when a new email is given, the model will automatically predict whether the email has spam or not. So this is yet another example of supervised learning. So here we have set of label data, and the labels that are assigned to this input data are the various shapes: hexagon, square, and triangle. So this pattern is given to the ML model. So the model trains the data, and when new set of test data is given, say for example here two shapes are given, and the model is able to predict automatically that the given shape is square and triangle. So this is what is supervised learning. Now in the case of unsupervised learning, as I told you, the model works on unlabeled data. So here it allows the model to work on its own in order to discover pattern and information that was previously undetected. So the machine learning is able to find hidden pattern in unlabeled data, and unsupervised learning problems are grouped into clusters and association rule mining. And the algorithms that can be used for this unsupervised learning are K-means algorithm, hierarchical clustering, market basket analysis, etc. So let us take an example of customer segmentation. So we want to give a set of customer data to the machine learning model. The machine learning model identifies the pattern or behavior of the customer from the data that we have given. Based on that, the machine learning model will be able to group the customers into weekend buyers, young customers, senior citizen customers, and so on. So here clustering is formed based on the data that we have given. So this is what is unsupervised learning. Now we have yet another example for unsupervised learning where we have given set of fruits as an input to the ML model. The ML model will look into the pattern of the fruit and the size and the color of the fruit, and it is able to build a model, and based on that it is able to group the fruits into apples and pears. So this is what is clustering, where it groups the similar items together. The ML model is able to group the similar items together, and therefore when a set of data, set of fruits is given, the ML model will be able to group apples as one cluster and pears as another cluster. So then we have semi-supervised learning. Here we give mixed amount of labeled data and large amount of unlabeled data to train the model. and the algorithms that are used for this semi-supervised learning are self-training and graph-based methods, and we have much more algorithms. So, one example that I can cite for this semi-supervised learning is that medical diagnosis with limited label records. So, if you look into this slide, we can see that small set of patient records with known diagnosis is found out, and large set of patient records without labels are there. So, we have some amount of label data and we have large amount of unlabeled data. So, what the machine learning model does is that based on the learning it had from the labeled data, it assigns the label to the unlabeled data, okay, and based on that it builds a model and it gives a prediction or output for the algorithm. So, this again explains how semi-supervised learning works. So, here we have a mixture of labeled data and unlabeled data. So, what the ML model does is that based on the labeled data, it is try to assign label to the unlabeled data, and it forms what is called as pseudo labeled data set, and based on the pseudo labeled data set, the machine learning algorithm is able to do predictions. So, when we give a set of data, here some shapes that are given here for prediction. So, what this algorithm does, based on the pseudo labeled data set, it is able to predict whether the given shape is square, rectangle or triangle. So, this is how semi-supervised learning works. Now, we are going to see next type of machine learning algorithm, reinforcement learning. So, in this approach, machine learning models are trained to make a series of decisions based on the rewards and feedback they receive from their actions. So, agent learns by interacting with an environment and receiving rewards. So, the machine learning algorithm helps to make series of decisions based on the rewards and feedback that it receives. So, here we have two important concepts, agent and the reward. Agent is the one who is going to perform the algorithm, and based on the performance, based on the actions that are performed by the agent, rewards will be given. So, one example for this is game playing, and the algorithms that can be used for this reinforcement learning are Q learning, deep Q network, etc. Now, in the case of game playing, the environment is considered to be the chessboard and set of rules, and the agent who is going to play the algorithm, here we are going to make AI to make moves. So, AI is going to play the chess, and therefore, agent here is AI algorithm. AI algorithm has to make the moves based on the set of rules that is given in the environment, and the reward here is winning the game. Suppose if the game is won, then we say that it is positive reward, and if the game is lost, we say that it is a negative reward. So, here AI learns optimal strategies through self-play. So, what I try to say here is, here the machine learning model tries to learn by itself by giving sequence of action. If the actions are correct, the ML model is going to get the feedback and the reward. Yeah, what we learn from this model is that the environment teaches the agent some pattern. So, the agent has to understand the pattern and do the actions accordingly. If the actions are correct, the rewards are given. So, the agent is supposed to store the pattern and do the necessary sequence of actions. So, this is what is reinforcement learning. Now, this is the machine learning workflow, where we have set of steps to be followed in order to implement any machine learning algorithm. So, the first step is the data collection. Then we have data pre-processing. This is where we have to do data cleansing, dimensionality reduction and feature extraction of data. Then based on the data that we have in hand, based on the analysis that we have to do, we have to choose the right model. Once the model is chosen, we have to train the model, as we have discussed in the earlier types of machine learning algorithm. Then the model has to be evaluated whether it is giving correct result or not, whether the predictions are correct or not, whether the outcomes are correct or not. So, for that we have to evaluate the model based on some parameters, and then we have to do hyperparameter tuning and optimization, which means that we train the model not only with the training data, we give combination of data and we do cross validation of the data in order to do this hyperparameter tuning and optimization, and finally the predictions will be done and it will be deployed. So, these are the steps to be followed while we do the machine learning algorithm implementation. So, these are some of the ML algorithms that are already available, we have linear regression, logistic regression and so on. We have a specific algorithm for each type of learning. Say for example, linear regression is used for supervised learning and it has a specific use case like predicting continuous values or predicting customer behavior or predicting whether an email is spam or not. These kind of predictions can be done with the help of the supervised learning and by implementing through linear regression. And we have algorithms like k-means clustering which can be used for unsupervised learning. Here we can use this model for segmenting customer data, and we have random forest algorithm again which can be used for supervised learning and so on. So we have several algorithms available under supervised learning, unsupervised learning, semi-supervised learning, and each of these algorithms can build its own model and predict its outcome. So these are some of the evaluation metrics that can be used in order to assess whether the algorithm is performing well or not. So accuracy is one particular parameter that can be used in order to judge whether ML algorithm is performing well or not. Yet another parameters are precision and recall, FN score. All these are important parameters that can be used in order to judge the performance of the algorithm. So these are some of the applications of machine learning. As I told you in the beginning of my slide, that machine learning is used in almost in all industries. Machine learning is used for e-commerce, in healthcare, finance, autonomous vehicles, chatbots, media side, etc. In almost all modern industries, in almost all domains, machine learning is being used. So what are the tools that can be used for machine learning? How we can implement these algorithms? What knowledge we should know in order to implement these algorithms and get benefit out of it? So if you have to do a machine learning implementation of a particular data, then we need to know programming languages like Python or R, and we have to use certain libraries and frameworks which help us to do the machine learning model. Like we can use TensorFlow, Scikit, all this we can use, and we also can use Veka in order to do the implementation of the ML algorithms. And in order to manage and store data, we can use Jupyter Notebook and Google Colab. So these are the programming languages and libraries that one should know in order to implement machine learning and get benefit out of this particular technology. Yeah, if one wants to do some small case study on machine learning, we can take a problem like this, like we want to predict whether a bank customer will stay with the bank or whether he will leave the bank. So in order to do this analysis, first we should take the input data. So the data should be collected from the bank. So normally we should take the customer data in order to check whether the customer will stick with the bank or whether he will leave. So in the case of customer data, we take some features or some input data like age of the customer, balance, number of transactions he had in the bank and so on. Then the data cleansing has to be done in the pre-processing stage. Then we have to train a model. So this model can be trained using several algorithms. It can be trained using logistic regression model, and based on the model, based on the prediction that is given by the model, we have to evaluate the performance of the algorithm using accuracy and FN score. So if the accuracy turns out to be more than 90%, then this learning can be taken by the bank in order to retain the customers without leaving from the bank. So finally, this is a summary of the learning that we had today. So machine learning enables system to learn from data. We have seen different types of machine learning algorithms: supervised, unsupervised, semi-supervised and reinforcement learning. And the ML process involves data handling, data training and evaluation of the model. We had lot of real-time application based on this machine learning algorithms. So we have also seen what are the tools and libraries that you can use in order to implement your machine learning algorithms. Thank you.